Assume that the U.S. Mint manufactures dollar coins so that the standard deviation is 0.0410 grams. The accompanying list contains weights, grams of dollar coins manufactured with a new process designed to decrease the standard deviation so that it is less than 0.0410 grams. This sample has these summary statistics where n is equal to 16, the sample mean is 8.065 grams, the sample standard deviation is 0.03 grams. Now, a 0.01 significance level is used to test the claim that the sample is from a population with a standard deviation less than 0.0410 grams. The null and the alternative hypothesis is given. The null is that the population standard deviation is 0.0410, and the alternative is that the population standard deviation is less than 0.0410 grams. Now, for this sample data, we get a p-value of 0.0143 when testing the claim that the population standard deviation is less than 0.0410 grams. So they're asking us, what should we conclude about the null hypothesis? So it's important to kind of go through the entire process just so that we can check our numbers here. But before we do that, let's take the data. So here's our data, and we're going to open this up in a StatCrunch. Okay, and then what we're going to do is we're going to take this data, and then what we're going to do is go to Summary Stats, go to Columns, and then let's find so select the column, and then we're going to find the sample standard deviation. So let's go ahead and do that, and there is our sample standard deviation. I'm going to go ahead and then copy this into our notebook. Okay, so here's our sample standard deviation. Now, if you notice, the sample standard deviation is rounded to 2 decimal places. In this case, it would round to 0.03. But we want to use, we don't want to round in order to find the proper test statistic to give us the p-value here. So before we move any further, let's take a look at the claim. So the claim states the following. We want to test the claim that the sample is from a population with a standard deviation that is less than 0.0410. And so now let's identify the following information that we need. Well, we can see that the sample size is given, so we know that n is equal to 16. Okay, we also know that the sample standard deviation is given here. So I'm going to use this number here, the one we collected from the data. And so if we round that to 6 decimal places, we get 0.025054. And then we also know that the population standard deviation from the null hypothesis is 0.0410. Okay. Now, when we check the requirements, okay, the sample is a simple random sample and the population has a normal distribution. And then the QQ plot wants to show that the data is normally distributed. So let's go ahead and do that. So when we take a look at the data here, we're going to go to Graph, scroll all the way down to where it says QQ plot, select the column, select Compute, and this confirms that our data closely resembles a normal distribution. So therefore it passes the requirements for that. Okay, so now let's state the claim and the opposite of the claim just to check that what they got for their null and the alternative hypothesis. What we saw from the claim that we highlighted was that the population standard deviation is going to be less than 0.0410 grams. And therefore the opposite of the claim would then be that it's greater than or equal to 0.0410 grams. And then to verify the null and the alternative hypothesis, remember that the null always contains the equality sign, and then we have the alternative. So the equality for the null means that the population standard deviation is going to equal 0.0410, and we can see that the equality is in the opposite of the claim. And therefore the claim would then apply to the alternative where we have the population standard deviation is less than 0.0410, which checks. Okay, now also we want to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Because it's less than, we would say that this is a left tail test. Okay, and if we go down a little further, now we need to test the significance level alpha. Well, up here, they want us to test it at a 0.01 significance level. So therefore, we know alpha is equal to 0.01. Okay, now the next step is that we want to then find the test statistic for testing a claim about the standard deviation or variance. Well, in this case, we're not given that, but let's just use our numbers to verify that. We know that n is equal to 16, so when we plug in our formula, we have n minus 1 times the sample standard deviation squared, which we round it to 6 decimals. So that's 0.025, 0.054. Now we're going to square that number, and then we're going to divide that by the population standard deviation, which is 0.0410 squared. And then we're going to round it to 3 decimal places. So let's go ahead and do that. So we have 16 minus 1, which is 15. We're going to multiply that by 0.025054, and then we're going to square that. And then we're going to divide it by 0.0410 and square that. And then we get 5.601. So rounding that to 3 decimal places, we get 5.601 as our test statistic. Okay, so now since they're using the p-value method, we're going to draw the curve and then label the and then label where we can find the p-value. Now recall here that since we're dealing with the standard deviation, we have a right-tailed distribution for the bell curve. We also know that this is a left-tailed test, so that we're looking for this shaded area here. And we know that the test statistic that we found is equal to 5.601. So that means when we want to find the p-value, we're looking for the probability of when our test statistic is going to be less than or equal to 5.601. Okay, now we also need to know what the degrees of freedom. So the degrees of freedom is going to be the sample size, which is 16 minus 1, which gives us 15. Now up here you can see that they give us the p-value of 0.0143, but let's go ahead and use StatCrunch. So we're going to come here in StatCrunch. We're going to go to Stat, and then we're going to scroll down to Calculators. And then from Calculators, we're going to select chi-square, because that's the test statistic that we're using. We're going to put in the degrees of freedom, which represents 15, and less than or equal to, and then we're going to put in the test statistic of 5.601. And then you can see that we get the p-value to be 0.0143. So, and that matches the p-value that we got here in the problem. And so now we want to then make a decision. So we're going to compare the p-value with the significance level. So we have 0.0143 as our p-value, and we know the significance level is 0.01. And if we add 2 zeros to the end of that, you can see that this p-value is going to be greater than the significance level. Now, if the p-value is less than or equal to the significance level, we reject the null. If the p-value is greater than the significance level, then we fail to reject the null. And in this case, we're going to fail to reject the null hypothesis. Now let's take a look at the question here. It says, what should we conclude about the null hypothesis? Well, we're going to fail to reject the null hypothesis. Let's check our answer, and there's our result. Now we need to determine what would be our conclusion. Okay, now with the conclusion, we need to come back and look at the original claim. The original claim includes a less than sign. So we do not have an equality. So we have 4 options. The original claim does not include equality. So those are the first 2 options. The original claim includes equality as the last 2 options. Well, it does not include equality, so we're not going to use those 2. Now, since it did not include the equality and we failed to reject the null, that means we're going to now not use that one and use the second one here. So we're going to say that there is not sufficient evidence to support the claim followed by the original claim. So we're going to say that there is not sufficient evidence to support the claim that the sample is from a population with a standard deviation less than 0.0410 grams. Check our answer, and then there is our result. So what do these results suggest about the new minting process? Well, since we failed to reject the null hypothesis, we would say based on this result, the new minting process does not appear to be significantly better or worse than the old method, and since there is not evidence that the weights of coins produced by this process have a significantly lower variance. Check our answer, and there is our result.